Okay, dot and cross, right? I think a lot of students think they are very confident in this dot and cross. They would think that, oh, it's very easy to do. But I wish to let you all know for dot and cross, right? Usually in big major exams, dot and cross are actually rather difficult to do. Okay, most of the time we'll try to give very challenging molecules. Okay, we definitely won't give you like BF4, something like that. Okay, all the H2O, all the normal molecules. We won't give you that. Okay, we'll give you something that is like a bit more challenging so that you guys have a challenge lah. Okay, if not the dot and cross is too easy, it's too easy to score. Okay, so typically a very easy concept, you tend to have a very hard question. Okay, those type of hard concepts question typically tend to be very easy. Okay, that's my observation across the years. Okay, so we start off with this molecule N2F2. Okay, so if you have been doing your VSEPR very consistently, right, you'll realize that straight off the bat, very quickly, N has 5 valence electron, F have 7. Okay, so most likely N will be in the middle. Okay, so your dot and cross, right, you want to put N, your N atoms as the middle atom, and then you have 2 fluorine at the side. Okay, because your fluorine, right, only needs one one covalent bond, and then you achieve octet already because it started off with 7. Okay, so you just need one more. Nitrogen needs like 3 covalent bond. Okay, so we'll put nitrogen in the middle. I think I already have an idea. Your fluorine and nitrogen will form like this, one bond. Okay, and then your F is already done. So all you need to do, maybe you just fill in the rest of your electrons for F. So fluorine is actually already done. That's it for fluorine. But for nitrogen, not yet, right? For nitrogen A, it seems that, okay, so we still have another 4 electrons. What do we want to do with it? Probably we can form a double bond in the middle, right? A double bond in the middle, like this. 1, 2. Actually, I should alternate, but maybe let me use a different color. Okay, 1, 2. Okay, so now N, right, has used up 3, and it has 3 bonds, which means that it's left with 2 more electrons on each nitrogen. So 2 more electrons, I can basically just form a lone pair. Because we also need to be careful, right, that nitrogen, it does not exceed octet configuration. Okay, so you shouldn't like take all the 4 bonds and try to like 4 electrons and try to form like quadruple bond, whatever that is. Okay, so now we have what? 1 double bond in the middle, 1 single bond at the side, and then 1 lone pair. Okay, so very nicely, both nitrogen achieve octet as well. Okay, both nitrogen achieve octet as well. Okay, so this will be your dot and cross. Let me show you the typed out version. This is the typed out version. So you have 1 single bond, 1 double bond in the middle, and a lone pair. 1 single bond, double bond in the middle, and then a lone pair. Okay, so how do you draw the Lewis structure? Lewis structure, basically you put the 2 nitrogen in the middle. So you have a single bond here to F, another single bond to F, and remember you still have the lone pair here on each nitrogen. Okay, so the shape around each nitrogen, right, it should be, I would say, 2 bond pair and 1 lone pair. It should be a bent shape. Okay, so the shape is bent around each nitrogen. Okay, so bend shape around each nitrogen. So the bond angle here, trigonal, planar, is 120, but because you have a lone pair, you should go down to 119 degrees around each nitrogen atom. Okay, so that's it for N2F2. I hope you guys understood this part. Now let's go on to this CN2 with 2 minus charge. I think this ion is a little bit like novel to you guys. I don't think we have seen CN2 2 minus. I don't think so. Okay, so prior to doing this, I don't remember seeing something like this as well. So CN2, okay, let's see. Okay, so we have 2 nitrogen. So even though nitrogen, it has more valence electron, right, I think carbon should be in the middle. Okay, so that's my feel. Carbon should be in the middle and then surrounded by both nitrogen. Okay, a negative charge, right? A negative charge would actually be given to the more electronegative element. So in this case, it's nitrogen. So we want to give each one of them one extra electron, okay, because cannot play favoritism, right? So each one will get one extra electron. So we have nitrogen getting one extra, so maybe dot cross. Let's just put a single bond first, cross dot. Okay, so this N has, okay, maybe you can form another bond here, another bond here. Interestingly enough, after forming two double bond, right, it looks like the middle C is already done with the octet. Yes, fulfilled its octet. Okay, now we look at the nitrogen, right? Because nitrogen has 5 valence electron, carbon has 4. Okay, so nitrogen used up 2 already, still left 3 plus 1 extra electron outside. So it means that each of the nitrogen have another 4 more electron, which means that there is 2 lone pair lah. Okay, 1 lone pair and 2 lone pair. Okay, so each one having 2 lone pairs. That's it. Okay, so the whole thing, once you're done with it, remember for ions, you need to bracket up and put a 2 minus right there. Okay, as usual, I want to show you the typed out version. This version definitely looks a bit nicer. Okay, for the shape, how will you draw it? Is C double bond N as well. Frame it up. 2 minus. Okay, so it is a linear shape. Linear shape. How to spell? Wrong spelling. Linear. Okay, linear shape. Then linear shape obviously is 180 degrees.